So now we're going to do some more complicated examples with truth tables. For example, we want to write a truth table for this statement, if P then not Q, or not Q and P. So we set up our table. We have two variables in this expression, in this statement. So we set up just the two variables, P and Q. Now, in order to figure out the truth table, in order to ultimately figure out the values for this, we need to break it down. We need to work on bit part by part. So we're going to need to figure out this, and we're going to need to figure out this, right? In other words, we find the results for each of those. But in order to do that, we'll first have to figure out the value of not Q. First, let's figure out not Q, and then we can do if P then not Q, and then we can do not Q and P, and then we can finally put that all together and find the final results. Okay, so we're going to have a few columns in our table. So we're going to do not Q. That's one thing we have to do. And then once we do that, we can do if P then not Q, figure out what the value of that is. And then once we've done that, we can do if not, then we can do not Q and P. And then finally, once we've done these two columns, we can now do this and get the final results. So that's what we're going to do. So first, we have to fill out the possible value, all the possible values of P and Q. So we use our standard procedure. We're in the right column, we put alternating true and false, true, false, true, false. And then in the next column, in the left column, we put groups of two, true, true, false, false. Okay, now we've got to do this column, not Q. So what is the value of not Q? Well, this is pretty simple. Not Q is just the opposite of whatever Q is. So when Q is true, not Q becomes false, and so on. So we get false, true, true. Now that we have the value of not Q, we can figure out what is if P then not Q. So let's see. So if P is true, okay, and not Q is false, then what is going to be if P then not Q? Well, we have something that's true and something that's false. So this should be false according to the truth table for the conditional. Next, if P is, in the case that P is true and not Q is true, the result is true. When P is false and not Q is false, the result is true. In the case where P is false and not Q is true, the result is true. Okay, so we've done if P then not Q. Next, we have to do not Q and P. So here we're looking at this column. We're going to be looking at the not Q column, and we're going to be looking at P, and we're going to be comparing them with and. So false and true, that's false. True and true is true. False and false is false. True and false is false. Okay, and then finally we can do the last column. So in the last column, we're looking at these two columns, right? The two previous ones in this case, but these two columns, and we are comparing them with or. So we're going to do false. Whoops, let's go back. False or false. That's false. True or true. That's true. True or false, that's true. True or false, that is true. So this column here, which I've put in bold, is the final results of this truth table. So what does this truth table tell us? Well, it tells us that, for example, when a case where P is true and Q is false, the value of this entire thing is going to be true, as we see here. And it tells you the final value of this expression for all possible combinations of truth values for P and Q. So it covers the case when both are true, when P is true and Q is false, when Q is, and then when Q is false and, when P is false and Q is true, and then when they're both false, right? So it covers all possible cases, all possible combinations of truth values for P and Q, and it tells you in each case what the value of the statement is going to be. Another example, write a truth table for this. P and Q or R, if and only if Q, X, or R. Now notice here we have 3 variables, P, Q, and R. So the table is going to have to be bigger. Now, something to think about is how many different combinations of truth values are there that can be assigned to P, Q, and R. So in the previous example, we had 2 variables, and there were 4 different possible combinations of truth values. And that's why we had 4 rows in the table, not counting the headers, right? But in the main part of the table, we had 4 rows because there are 4 possible combinations of truth values that can be assigned to P and Q. Each one could be true or false. So now if we have 3 variables, how many rows will the main part of our table have? In other words, how many different possible combinations of truth values will there be? Well, as we'll see, there will be 8, right? And that should be reasonable because that's 2 to the power of 3. Okay, so we have our 3 variables, P, Q, and R. Now here we're going to extend our procedure for filling in the possible values of P, Q, and R. So we start with the rightmost column of these variable columns, and right, I mean this is the rightmost column, but I mean the rightmost column of the 3 variable columns, and we do alternating true and false. So true, false, true, false, true, false, true, false. Remember, 8 rows because there are 3 variables, and 2 to the power of 3 is 8. Next, for the next column, meaning moving towards the left, we do groups of 2. So true, true, false, false, true, true, false, false. And then for the leftmost column, for P here, we're going to do groups of 4. Okay, so groups of 1, then groups of 2, then groups of 4. We're going up in powers of 2, right? So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, right? So a group of 4 truths and a group of 4 falses. Using this procedure, using this method, we can cover all possible combinations of truth values for P, Q, and R, right? So if you try listing out all possible ways of assigning either true or false for each of P, Q, and R, you would get these 8 possibilities. Okay, so in other words, for example, you might have all 3 of them be true. You might have P be true, Q be true, and R as false. And then, for example, you might have P as true, Q as false, and R as true, and so on. Okay, so doing this, we cover all possible combinations. All right, so now what do we need to do? So we need to do P and something. So that means before we can do this and, we have to figure out what this something is. Now, this something is a whole complicated expression. So we'll break it down into parts. So we have one part here, Q and R. So we'll have one thing here for Q and R. Sorry, Q or R, rather, Q or R. We have another thing here for Q, X, or R. So we'll have another column for that. Then we have to take those 2 previous things and combine them into one thing. Well, combine them using if and only if. And then finally, we can take P and this if and only if part and combine them using and. So we're going to go ahead and fill in Q or R. So go ahead and do that. And here it is. Then we go ahead and fill in Q, X, or R. So there it is. Now we go ahead and take these 2 previous columns, Q or R and Q, X, or R, right? We have Q or R and Q, X, or R, and we're doing if and only if. So in other words, it's going to be true if and only if false, which is going to be false, and so on. So go do that column. And then finally, we're going to take this column and combine it with P with and. So P and this previous column. So it's going to be true and false, which is going to be false, and so on. So go do that column, and it's here. So this is our final column, and it tells us what all the truth values for each possible combination of P, Q, and R. It tells us what the truth value of the statement is.